Today we are going to learn about the nomenclature of an organic compound, or how do we name an organic compound. Today also we study about the methyl group, or what saturated hydrocarbons or unsaturated hydrocarbons are. As you know, the hydrocarbons are divided into two big categories. They are aliphatic and cyclic hydrocarbons. Again, the aliphatic hydrocarbons are divided into saturated hydrocarbon and unsaturated hydrocarbon. In our syllabus, we study about saturated hydrocarbon and unsaturated hydrocarbon. Again, the saturated hydrocarbon can have a subdivision that is called alkanes. And the same way, the unsaturated hydrocarbons are divided into two classes. They are called alkenes and alkynes. We are going to see what are the general formula, how do we name them, and they are bonding, the arrangement of carbon atoms, carbon hydrogen bonding. These are the things we are going to study today. So first of all, we see what are the word roots for the nomenclature. For naming a compound, we need a word root. One example, if you write, suppose all of you know CH4 is known as methane. CH4 is known as methane. So this meth, M-E-T-H, meth and A-N-E, they come from two different aspects. So the meth, we say the word root, and A-N-E, as I already told you, is a part of alkane. The same way we have alkene there, alkyne there. So before studying the naming, what we supposed to study? We study the word roots. If number of carbon atoms are 1 in a chain, so we use the word root meth. And if it is 2, carbon atoms are 2, we use eth. And carbon 3, C is equal to 3, we use prop. And C is equal to 4, we use but, B-U-T. And C is equal to 5, we use pent. The same way, or C is equal to 6, we use the word hex, word root hex. Or C is equal to 7, we can use the word root hept. The same way, if C is equal to 8, we use oct. And if C is equal to 9, non. Or if C is equal to 10, we use dec. Such a way, especially the first 5 or maybe till 7, we are supposed to keep it in mind. Okay, 1, met, eth, prop, but, pent, hex, hept, oct, etc. Here I made 3 columns, one for alkane, alkene and alkyne. Also, one more column is given for the number of carbon atoms. So first I write if number of carbons are 1 carbon there. Then how do we write? So here you see a general formula for alkane, a general formula for alkene, and also for alkyne. And also you see here, it is a single bond compound. Alkane family means it's a single bond family. Or alkanes are double bond. Minimum between 2 carbons there should be a double bond. And at least between 2 carbons there should be a triple bond, that is called alkynes. Also we use the suffix along with the word root. Word root already we have seen. Suppose meth plus ane, methane. Or suppose you use the word root eth with ene, ethene. Or eth with yne, ethine. So such a suffix also we have to use in this section. Let's start with carbon is equal to 1. So assign the value 1 for the variable n. Wherever n there, you substitute the value 1. So C1 H2 into 1 plus 2. So we get CH4. The CH4 we can say it is a molecular formula. Molecular formula. Okay. So how do we expand this CH4? Can we expand as C single bond H, single bond H, single bond H and single bond H. This is called the structural formula. Structural formula. And you know here, alkene, minimum 2 carbons are compulsory. Then only we can make carbon to carbon double bond. As we have only 1 carbon, there is no alkene formed with 1 carbon. The same way here, we cannot have any alkyne with 1 carbon as it needs minimum 2 carbons. Between 2 carbon, double bond is required. So C is equal to 1, methane can be formed and it is the simplest alkane. Mind, it is the simplest alkane. with 1 carbon. So let us see what with C is equal to 2. C is equal to 2. So substitute 2 here. C2H2 into 2 plus 2. That means C2H6. This is the molecular formula. Okay. This is a molecular formula. Okay. So I am going to expand it so that we get the structural formula. 2 carbon there. 1 carbon and second carbon. As it is, as we use the formula CnH2n plus 2, between the carbon only single bond comes, no other bonds. Okay. So 2 carbon over, the rest bondings are to be filled with hydrogen. So this is called the structural formula. Okay, molecular formula, structural formula. And you see, we can again slightly make it condense the structural formula. How do we condense? This area. So take it together. That is called CH3. Then single bond and the right side one. So you get CH3. So CH3 or H3C. For showing the bond, I have written as H3C. Okay, CH3, we read it as H3C. This is called the condensed formula. Condensed formula, and it is a structural formula and it is a molecular formula. Okay, structural, molecular, condensed. Then what is the name of the compounds? So there are 2 carbon there, the C is equal to 2. What is the word root we use? We use the word root eth. And since it is only single bond compounds are alkane. So we use the suffix ane. So eth plus ane, we get the word ethane. The compound is known as ethane. C2H6 is known as ethane. Now we see what alkene is formed with C is equal to 2. So we see C2 and H2 into 2. So C2H2 into 2, 4. So we expand so that we get to the structural formula. C and C, 2 C's are there. So what comes between double bond there. The rest, it is to be filled with hydrogen. 1 hydrogen, second hydrogen, and here 1 hydrogen, second hydrogen. So that if once you check it with whether carbon satisfies the all 4 bonds. First carbon, 1, 2, 3, 4. The same as second carbon, 1, 2, 3, 4. 4 bonds are satisfied. So it is a structural formula. Same way you make it condensed. So this area, make it together. CH2, double bond, CH2. So this is known as the condensed formula. Molecular formula, structural formula, condensed formula. Then what is the name of this compound? Since 2 carbon there, as usual, it is eth. And as it is double bond, so we use the suffix ene. So eth, ene, ethene. The compound is known as ethene. The same way, come to the alkyne family. C2H2 into 2, 4 minus 2, H2, C2H2 we get. So what's supposed to be here? 2 carbon, between 2 carbon, double bond is there, triple bond is there. Okay, between 2 carbon, triple bond is there. So first carbon with 3 bond and the fourth bond with hydrogen. Either you can write left side, top or bottom. Anyway, you write. For the time being, I write left side. Okay, and here the fourth bond. 3 bond, second carbon with 3 bond with the first carbon and the fourth bond with hydrogen. So you make it condensed, this one together. CH, then bond, then the second CH, triple bond, CH. Okay, how do we name this one? 2 carbon, eth. And triple bond compounds are alkyne. So we use the suffix YN. So we got 3 compounds, ethane, ethene and ethyne with the carbon is equal to 2. So we try another compound, C is equal to 4. Okay, so we try to get corresponding alkane and alkyne. The first one C is equal to 4. So C4, H4 into 2, 8 plus 2, 10. So we get the molecular formula C4H10. So how do we write the structural formula? So only single bond there. So it is simple to write 1, 2, 3, 4. 1, 2, 3, 4 single bond. So the rest bonds are filled with hydrogen. First hydrogen 2, 3, 4, 5, 6, 7, 8, 9 and 10 hydrogen. How do you make the condensed formula? So first CH3, single bond CH2, CH2, CH3. CH3, then bond, CH2, then bond, CH2 bond, CH3. So this is known as the condensed formula, and this is called the structural formula, and this is the molecular formula. Okay, and what is the name of the compound? For carbon there, we use the word root but, single bond, so suffix ane, but, ane, it is called butane. So come to the alkyl. So what it could be? So C4, 4 into 2, 8, H8. So it is a molecular formula. So we have 4 carbon there. So where do we give the double bond? No problem. In between any 2 carbon, you can give the double bond. Okay. Suppose I write here. And the rest, all the places, it is single bond. Okay. So first 1 bond is over. 2, 3, 4. 1, 2, 3, and 4, 2. It is see 2, 3, 4, 5 bond there. So it should not have happened 2, 3, 4 only. So 1 H I remove. The third carbon 1, 2, 3 already there, 4. Either you can keep this H top or also at the bottom, no problem there. And here 1, 2, 3, 4. Okay. So this is a structural formula. And how to make the condensed formula? CH3, single bond, CH, double bond, CH, single bond, CH3. Oh, the name of the compound. What is the name of the compound? We have a 4. 4 means but. For ENE, it is called butene. The compound is butene. So if we come to the alkyl, C4, H8, 4 into 8 minus 2, 6, C4, H6. Okay. So how do we make? 1, 2, 3, 4. 1, 2, 3, 4. In between any 2 carbon. Okay, in between any 2 carbon, we use what? Triple bond. So here we use triple bond. The rest, all the places, only single bond. First carbon, first bond is over. Second bond, third bond, fourth bond. Here you see 3 plus 1, 4 bonds already over. So you don't add any hydrogen there. And the third carbon, 3 bond towards the second carbon and 1 bond towards the last carbon. 4 bonds over. Then you consider the last carbon. Only 1 bond is there. Second bond, third bond and fourth bond. So C4H6. This is the structural formula. About the condensed formula, CH3, single bond, C, triple bond, C, single bond, CH3. Okay. How do we name? 4 carbon, same word root but, and suffix YN. So such a way you can also try with C is equal to 5, C is equal to 6, 7 or 8, etc. Make such 4 columns and correspondingly you fill the data. Now we see what alkyl groups are. Alkyl group. Okay. So we have seen alkane, alkene and alkyl. Now it is alkyl group. Okay. Alkane, alkene, alkyne and alkyl. Fourth one. Okay. So it is simple. If you remove one hydrogen from alkane, we get an alkyl group. Alkane minus hydrogen. We get what? Alkyl. If we remove one hydrogen from an alkane, we get alkyl group. Okay. Let us see one example. We see CH4. How do you write CH4? The structure of CH4: single bond, single bond, single bond, single bond. And you remove one H. So what we get? We get single bond H, carbon single bond H, single bond H, single bond H, and one place is vacant. So that is called CH3. It is what? It is methane. Methane is an alkane. Alkane. What I said? Alkane minus hydrogen. Alkane minus hydrogen. So that we get alkyl. Okay. What is the name of this alkyl? If it is methane, it can be called methyl. YL. methyl, methyl. So methane become methyl. How? By removing one hydrogen. And you don't worry here, one bond is free. It is not filled. Here somebody can be any functional group or any compound, suppose fluorine, chlorine, bromine, or what, OH group, alcohol group. Anybody can be here. Okay. Or COH group. So that the fourth place will be filled. It can have a general formula. What is the general formula? The CnH2n plus 1, because CnH2n plus 2, it was the formula of what? It was the formula of alkane. It was the formula of alkane. So alkane minus 1 hydrogen. So generally the formula comes as CnH2n plus 1. So it can be represented by a letter R. Okay, letter R means alkyl group. Okay, so we see 2-3 examples. See the table. Here we have 4 columns are there. The first column I write the alkane, the simplest alkane. What is the simplest alkane? Methane. So CH4. Okay, so I write methane. The name of the alkane is methane. So what we do? We remove one H here. We remove one H. So we get an alkyl CH and then we get CH3. What is the name of this CH3? It is called a methyl. Okay. And we see another one, C2H6. What the compound is? Ethane. The compound is ethane. So here also you remove one H. So that we get C2H5. C2H5 and one bond is free there, C2H5. So what do we call C2H5? It is ethyl. Ethyl. It is ethane and the alkyl is ethyl. So third one, C3H8, that is called a propane. Okay. So here also you remove one H. One H is removed. So we get C3H7 and one bond is free. So we get it is propane and it is called a propyl. Hope it is clear for you. Hope you have got a clear idea about the basics of nomenclature. So you have seen how do we name a simple alkane or simple alkene or an alkyne. Also we have seen what an alkyl group is. These all the terms, these all the things are required for the nomenclature of the long chain hydrocarbons, maybe along with the functional groups. So we meet soon along with the nomenclatures, along with the functional groups and long chain hydrocarbons. Thank you.